Okay. On this one, it says the average acceleration. Now, they gave us velocity. This is average rate of change. And average rate of change is always old school slope. Okay. So when it says average rate of change equals old school slope, it's not even a calculus problem. Okay, so let's calculate that then for this particular one. It says from 10 to 12, they've got to give us those values. Otherwise, we can't actually do it. So, and they did. So it goes from velocity of 5 to velocity of 3. All right, so here we go then. So the average acceleration is going to equal, so average rate change is going to equal, not an approximation. That was an approximation because we did not have the particular value at 8. But now we have these exactly, so we can find the average, whatever that next derivative is. Okay, so that's why it's called average rate of change. Okay, so the next derivative, if you're given velocity, is acceleration. So this is going to equal v of 12 minus v of 10 okay, divided by 12 minus 10. So it's just y2 minus y1. I mean, the slope you've been doing since, wow, probably 6th grade. Okay. So I already forgot. 12 was 3 and 10 was 5. Okay. So 12 was 3. 10, it was 5. Okay. Denominator is 2. And so what's that? That's negative 1. So it's negative 1. Now, this is talking about the average acceleration. So we had this velocity, which is, of course, in terms of, was it feet per second? And then we're dividing again by the number of seconds. So by the way, it was negative. So negative 1 feet per second squared. And so what does that mean? Well, that means traveling from t equals 10 to t equals 12, the velocity decreases by an average of 1 foot per second. All right, so I'll write that out. Okay. As the particle travels from t equals 10 to t equals 12, the velocity decreases by an average value of 1 foot per second. Something along those lines. All right, and then it says, okay, let the acceleration equal the derivative of velocity. Is there a time where the acceleration is equal to 0 between 0 and 15? Well, this is the same idea, but here's how we decide, okay? It's all about this value increasing or decreasing, okay? So as I'm traveling along here, I can see that this went up, okay? This went up. This went up. I'm not looking at the particular values, just the fact that it went up. Okay. Still going up. Still going up. Now we're talking about the velocity increasing. So that means acceleration, since that's going up, acceleration was positive through here from what I can tell. Okay. Again, you don't know what it's doing, but I just know between the average right there was definitely positive. All right. And so then this one goes up, and now check this out. Right here, for just one brief moment between 10 and 12, it went down. We saw that on the last problem. So it went down. All right. And then it went back up again. Okay, so if this were to be true, all right, so that means my velocities were increasing and then they had to have decreased. So in between here and here, I had to have a moment where the acceleration was zero. And also because the velocities were decreasing and then they started increasing again, same thing. I had to have a moment where the acceleration was zero. All right, so it's still intermediate value theorem, but now because the second derivative is also differentiable, therefore continuous, I'm guaranteed to have at least two zeros here. One in the interval one, because this went from a positive to a negative. So one of them had to happen somewhere in that interval, and then another one in that interval, because we had at the end of that traveling, we were positive. At the end of that, we had gone down. All right, so it was going up, and then at the end of this, we saw that it went down. So it had to happen here, and it had to happen there. So how do we say that? Since acceleration is differentiable and continuous, there are guaranteed a zero somewhere in the interval between 10 and 12, and another one at 12 and 15 on the intervals 10 to 12 and 12 to 15 due to the velocities increasing decreasing, and increasing again. Something like that will work just fine.